Hi, I'm Allie, a test prep tutor and strategist at Geek. Today, we're going to look at everything you need to know about ratio, percent, and fraction problems for the SAT and ACT math. Ratios, fractions, and percents, you can think of these as all part of one category of math problems on the SAT or ACT. They all deal with parts of a whole or the relationship between two values. Ratio problems rely on the relationship between two values like 3 to 2 or 1 to 5. Fraction problems deal with parts of a whole like 1/2 or 3/4. Percent problems use numbers in terms of their relationship with a whole of 100, like 65% or 30%. You may feel more comfortable with one of these concepts over the others, and that's okay. We're going to brush up on all of them so you can make sure you feel confident no matter what type of problem you see on test day. Let's start with ratios. Ratios express the relationship between two values that move together. And the ratio is the simplest version of that relationship. Let's say that you have a signature green paint that you make by mixing 2 parts blue paint with 3 parts yellow paint. We could say that this relationship between blue and yellow paint is 2 to 3. We can use this understanding of a ratio to answer all different types of questions on the SAT or ACT. We might see something like this. ABC Paint Company's signature spleen green paint is made by mixing 2 parts of blue paint and 3 parts of yellow paint. If the company needs to fill an order of 70 gallons of spleen paint, how many gallons of blue paint will they need? So we've already talked about this idea of the ratio of 2 parts blue to 3 parts yellow paint. But they're not really asking us what the ratio is, they're going a step further. And they're saying that we need to fill an order of 70 gallons, and how many gallons of blue paint would we need? The first step would of course be recognizing that this is actually a ratio problem. Once we know that, we can use this 3-step simple process. Figure out the number of total parts, divide the goal value by the number of total parts, and multiply the value of each part by the number of parts in the desired portion. With anything, ideally you do enough practice that this 3-step process becomes more intuitive than a memorized process, but either way, even if you memorize it, this can be really helpful on test day. So let's use this process to work through this problem. So first step, figure out the number of total parts. So in a 2 to 3 ratio, there are 5 total parts, right? 2 plus 3. And divide the goal value by the number of total parts. So our goal value is 70. So we want to divide 70 by 5. So 70 divided by 5 is 14. The third step is to multiply the value of each part by the number of parts in the desired portion. Okay, so this is where we take our number 2 number, so our number that we got from step 2, and we multiply it by the number of parts in the desired portion. So let's go back up to the problem for a second, and it's actually asking us how many gallons of blue paint do we need? And remember that there's 2 parts blue in this case, so we are going to multiply 14 by 2, and we get 28. Okay, so it might seem a little confusing at first, but this 3-step process will become more intuitive if you do some practice. Let's try another type of problem. This one's a little bit different. It's called a limiting factor ratio problem. So let's imagine you're preparing for the holiday season and you get some cards that you're going to mail out to your friends and family. And these are those like oversized cards that take a little bit of extra postage. So for each card that you mail out, you need 1 card, 1 envelope, and 2 stamps. So what are you going to run out of first if you have equal number of stamps, cards, and envelopes? This one's pretty easy, right? You can probably figure out that you're going to run out of stamps first because you need double the number of stamps that you need for envelopes and cards. And this is the idea of a limiting factor. Sometimes you have different ingredients or pieces that make up a whole of something, and it takes a different quantity of each of the pieces. And so whatever you have the least of in terms of their ratio to the other items, whichever thing you're going to run out of first, that is your limiting factor. So in this case, our stamps are our limiting factor. But on the SAT or ACT, we might see this asked in a little bit more complicated way. So let's look at an example of a problem like this. In order to make a single glucose molecule, 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms are needed. If 42 carbon atoms, 73 hydrogen atoms, and 41 oxygen atoms are present, what is the maximum number of glucose molecules that can be made? Okay, so this one's a little bit more complicated, right? It's not as intuitive as our card example, but that's okay. We can still use the same strategy in a sense that we used for our card example for this one. The idea here is to figure out how many glucose molecules each one of our supplies is good for. Essentially, we have all of these distinct supplies. How many glucose molecules could each of these supplies be used for? That will tell us whichever one is smallest, that's our limiting factor, and that's the answer to our question. Because if we don't have enough of one thing, it doesn't work, right? As soon as we run out of something, we're done for. We can't make any more glucose molecules. So let's work this out step by step. Let's first start with carbon atoms. So we have 42 and we need 6 to make each glucose molecule. So let's figure out how many glucose molecules we could make with our 42 carbon atoms. So let's divide 42 by 6 and we get 7. So we have enough carbon atoms to make 7 glucose molecules. Great. Now what about hydrogen? We have 73 hydrogen atoms. Let's divide that by 12 because that's how many hydrogen atoms it takes for each molecule. And we get 6 something. So we always want to round down because if we have a part of something, it's not enough to make a whole, right? We can't just round it up and count it as a whole. So we're going to round down and we get 6. And then lastly, oxygen atoms, 41 divided by 6. So here we also get 6 something. This one's a little bit closer to 7, but we still can't round up, we have to round down. So for that one, we also get 6. So if we look back, we have 7, 6, and 6. So our smallest number is 6, so that's how many molecules we're going to be able to make with the ingredients that they've given us. And that would be the answer to your problem here. We could make 6 glucose molecules. Now it's time to move on to fractions. Let's think about the fraction 2 over 3. We have a whole 3 and a given relationship to that whole, which is 2. We can also think of it as parts of a whole, where we have 2 of the 3 parts. Fractions don't just have to be part of a whole, though. We can also have fractions that are greater than a whole, like 5 over 2, which is also equivalent to 2.5, or 2.5 wholes. These are actually called improper fractions. In order to master fractions for the SAT or ACT, you need to be able to do these 4 things: reduce, add and subtract, multiply and divide, and convert to decimals. So let's start with reducing. What does it mean to reduce a fraction? Well, let's say we have 4 over 10 as our fraction. If we want to reduce this, it means get it to its simplest form. So in this case, we want to look for the greatest common factor that we have between our numerator and our denominator. So in this case, we can divide both the top and the bottom by 2. So if we divide the top by 2, we get 2. If we divide the bottom by 2, we get 5. There isn't a number bigger than 2 that 4 and 10 both have in common. So in this case, our greatest common factor is going to be 2. And so when we use that greatest common factor to divide both the top and the bottom by 2, we get our reduced fraction, or our simplest version of that fraction, which in this case is 2 over 5. And this can be really helpful when you have answer choices that are reduced, but the answer that you got when working it out is not reduced. So you need to be able to do that quick math to know that your answer choice is correct. Otherwise, you might be a little bit confused because the answer you got doesn't exactly look like the answer in the problem. So just make sure that you feel comfortable reducing fractions. Now, how about adding and subtracting fractions? The rule here is that you have to have the same denominator. So you must have this common denominator before you even start adding or subtracting fractions. Let's look at an example. 1/4 plus 2/3. Okay, so how do we actually get a common denominator here? This might be a little bit of a review, but you need to find the least common denominator or least common multiple of the denominators. Whatever way you've learned it is fine. It means the same thing. Basically, the least common multiple of the numbers on the bottom of our fractions. So one way you can do this is you can actually just list out all of the multiples of both of your denominators and find the number that's the same between them, that's the smallest. So let's practice this. So with 3 times 1 is 3, and then we can kind of go down the list, right? So 3, 6, 9, 12, 15. Okay, let's stop there. We don't want to get too crazy. Let's work with the 4 and see if we can find a common denominator or multiple. So 4 times 1 is 4, times 2 is 8, 12, 16. Okay, perfect. So we found 12. 12 is the smallest number on this list, on both lists, that's shared, right? So another way, if you're a little bit stuck on the test and you don't want to do this, you can always just multiply the denominators by themselves. That's always going to get you a common multiple or a common denominator. Even if it's not the least common, it's okay. You can probably still get to the answer choice. But you need to just understand this concept that you can't just add across the top. You have to have a common denominator first. Okay, so once we have a common denominator, how do we actually convert the fractions that we have into fractions that have a common denominator? Well, we want to think about it. So 1/4, if we think about the bottom, we want to get the bottom to 12. How do we get the bottom to 12? We multiply it by 3, right? 4 times 3 is 12. So whatever we do on the bottom, we have to do on the top. So that's going to make our fraction 3/12. And our other fraction, 2/3, how do we get the bottom of 2/3 to 12? We multiply it by 4, right? We have to do on the bottom what we do on the top. So let's multiply both top and bottom by 4. And we would get 8/12. Perfect. And now we can add right across the top and keep our denominators the same. So 8 plus 3 is 11. So our answer would be 11/12. Now, likely on the test, you're not going to see a problem that's just asking you to add fractions, but it's a skill that might be required in a more complicated problem. So it's important that you have this skill set as a foundation that can be used on other problems. The same thing applies for subtraction here. We're not going to go over an example of subtraction, but you'd want to do the exact same process. And then if you are subtracting, you're just going to subtract across the top instead of addition. So how about multiplying and dividing fractions? In some ways, this is a little bit easier because you don't have to have a common denominator. If we look at an example here, 1/2 times 3/4. So if this is the case, if you have a multiplication of fractions, you actually can just multiply straight across the top and straight across the bottom. So in this case, we would get 3/8. And sometimes you might need to simplify that. In this case, we don't need to, but that would be our answer. So what about dividing? If we want to divide 1/2 by 3/4, we can actually change the sign and flip our second fraction. And that allows us to not have to worry about doing any kind of real division here. We can treat it like a multiplication problem by simply flipping the second fraction. So we would get 1/2 times 4/3. So we would get 4 on the top and 6 on the bottom. And we could simplify that if we needed to, but that may be enough depending on the problem. The last thing that we're going to talk about is how to convert fractions to decimals. The key here is that you want to use your calculator. So this is just something you should be thinking about throughout the test. When do I need to use my calculator? When do I not? Some sections will allow you to use one, some won't. So when you do have that calculator, you want to make use of it when needed. So if all of the answer choices are in decimals, you probably want to be using your calculator pretty early on so you can be converting those fractions to decimals. And it's pretty simple, right? Let's say we have 3/4 as our fraction. We can simply do 3 divided by 4 in our calculator and get 0.75, and that's how you convert to a decimal. Now it's time to talk about percentages. Percentages are another way to express parts of a whole. You can have a percent that's less than 1, like 75%, or greater than 1, like 150%. And you can also convert percentages to decimals. So 75% can also be expressed as 0.75, or 150% could be expressed as 1.5. So again, less than 1 or greater than 1, both work. We can also multiply a decimal and turn it into a fraction. So 0.75 times 100 is 75%. Or 1.5 times 100 is 150%. So we can convert both ways. Oftentimes, working with the decimal version of a percent is easier than working with the percent itself. So say we had an 80% chance that event A happens and 60% chance that event B happens. There's a 48% chance that both event A and B happen because 0.8 times 0.6 is 0.48. That's just a lot easier math to do than trying to work with the percentages themselves. We can do quick addition, subtraction, multiplication on decimals versus percentages can get a little bit messy. So sometimes it can be wise to convert percentages on the SAT or ACT into their decimal form. Let's try another problem. This one's going to combine skills of percentages with survey design. We're not going to go into detail on what you need to know about survey design for the test, but it falls into the broader category of statistics and modeling for the SAT, so it's something you might want to look into if you're studying for that test. So let's take a look at this problem. A study was done on the weights of different types of fish in a lake. A random sample of fish were caught and marked in order to ensure that none were weighed more than once. The sample contained 100 catfish, of which 40% weighed more than 2 pounds. Which of the following conclusions is best supported by the sample data? The majority of all fish in the pond weigh less than 2 pounds. The average weight of all fish in the pond is approximately 2 pounds. Approximately 40% of all fish in the pond weigh more than 2 pounds. Approximately 40% of all catfish in the pond weigh more than 2 pounds. With a survey, so we're not dealing with like every single catfish in the entire lake. We are just randomly sampling. So whenever we randomly sample an area, we can draw some conclusions, but we can't say things for absolute certainty. So one thing that we notice here is that 40% weighed more than 2 pounds of the sample. So we can probably draw some conclusions about the larger population of fish. So we could say that approximately 40% of all catfish in the pond weigh more than 2 pounds. So one thing that just kind of keep in mind here is that this is mostly a survey question, but it also kind of requires you to understand the basics of percentages and how they work as parts of a whole. So in this case, our answer would be D, approximately 40% of all catfish in the pond weigh more than 2 pounds. For the SAT or ACT, you want to feel confident working with ratios, fractions, and percentages. They're all kind of related, but they require their own set of mathematics skills in order to do well on these question types on the SAT or ACT. You should be able to convert between fractions and percentages, and you should also be able to expand the values of any two related quantities. Thanks so much for joining me. If you're looking for more SAT and ACT prep content, make sure you subscribe, and you can also follow us at testgeek.com/blog.